Hello, welcome in this video. So if you have been around the internet and more especially in the space of web development and specifically in the world of JavaScript, at least of the recent years, you have seen a huge trend in TypeScript. Okay, so like everyone everywhere on all platforms, on all companies are asking for developers who actually know TypeScript. So it is have been all over the place, all over the internet, and people who have been doing JavaScript and they came from the JavaScript world. TypeScript is not something they are happy about. Like at least at the first, when you're just starting to write TypeScript, it is not something that is very easy to get into, more especially if you have never done it. Okay, so it is a nightmare if someone asks you, do you know TypeScript, and you even don't have any projects you can show in TypeScript. Okay, people have tried to learn TypeScript. Most of my friends, people message you and they tell you if you have a good resource for TypeScript. Clearly there is a need of learning TypeScript in the recent trends, and this is been seen in amount of projects that are now deployed using TypeScript. Okay, so at least you need to know very well TypeScript and how to use it even in bigger projects. Okay, so me personally, it was not easy to learn TypeScript, and that's why after learning TypeScript, at least the one I know right now, I just want to share with you how I break down these concepts of TypeScript, sometimes which are scary to get into, and we break down into actually understandable pieces. If you have been following my content, you know I explain step by step. Now, most people say I over explain, but that's actually where my strength lies. I explain concepts, and if you truly want to understand the concepts, you should take attention and take your time to learn something. Otherwise, people always want videos for 10 minutes, learn TypeScript in 10 minutes, learn TypeScript in 20 minutes. Really, you are not getting the core concept done really well. Okay, I'm not sure how long this tutorial is going to be, because this is going to be the first episode in the course I'm preparing. So there is a full course. I'm just going to explain to you at the end of this presentation. I will show you the full course, but at least for this, the beginners part, I'm just going to give it for free here on YouTube. Okay, so learning TypeScript is not something that is really easy if you have started with JavaScript. But if you have done, for instance, C++, Java, or you have any static language you have done, you will start getting into TypeScript is something more easy. But people, my friends who come from the self-taught and the JavaScript world, coming in TypeScript has never been easy. Okay, so that's why I decided to put this TypeScript course for beginners, and you're going to see how to use it in React and Next.js specifically, because this is where a huge massive trend is in. It is in more of React and specifically Next.js, and you're going to be looking at that. So there are so many questions when people ask themselves. TypeScript makes JavaScript hard. You write a lot of code. Why? I'm not sure if it is really necessary for me to learn TypeScript. So this is to inform you that you really need to learn TypeScript, because big projects and people who are working on teams right now, they have shaped their projects in TypeScript. So if you are going to get a freelance job or you are going to work on any team, they expect you to be knowing how to use TypeScript. So really, you need to know TypeScript. And this might not even be because of your own projects, but the fact that you want to work on other bigger projects with other people, you really need to know the stack that they are using, and therefore you need to learn TypeScript. Now, in the first, it's just like the way we learn Tailwind. At first, when you're using Tailwind, you think it is writing too much code, but in the long run, you actually enjoy writing it and it becomes fun. So TypeScript is in the same way. TypeScript at first is rewriting a lot of code, and you even ask yourself, why am I even writing all this code in the beginning? But as you continue writing it, it works as a documentation. You will start seeing your code, all of it documented, and everything moving on in the right way. And more especially, getting bugs before you reach production is one thing that saves you really amount of time. I can't constrain on just using TypeScript a lot. Me personally, I've been working in JavaScript. You know, all our big SaaS projects, we have built them in JavaScript. Okay. A lot of times when you're just going to production, you spend hours and hours figuring out the errors in production, but most of them actually comes in type errors. So when you're using TypeScript, you'll find that most of your errors are actually going to be really reduced to raw numbers. And this increases your production rates, whereby the app you send to production, and more specifically, if it worked on localhost using TypeScript, it is going to go successfully even in production. You are very sure in most cases you work on your project on localhost. When you go to deploy it, you have a lot of errors that actually went through your localhost. So TypeScript somehow reduces those errors, and you see those errors in real time, and therefore you actually need to write TypeScript. As I've said, as the more you write TypeScript, the more you get used to it. So we're just going to simply practice. Okay. There are other people who always find it hard to learn new languages. You are not alone. Most of us actually, like when you're learning a new language in web development or in programming at general, if they say you're going to learn this language and it's a new language, you have never done it, it's not something easy. Okay. Even in real life, you are going to learn any new language. Maybe you're learning Chinese or you're learning French. It is not easy at the beginning. Okay. So even learning a new language, really it is not easy. But I always break down into about 4 or 5 steps on how to actually learn a new programming language. Okay. So if you want to learn a new programming language, basically this is me how I normally do it. Okay. So first of all, you follow a video to learn the basics. So there are those people who normally say just go to the documentation, start the basics. Really it is not easy to just simply go to documentation and you start to play around, unless you're a senior developer and you know how you have been doing this. Now for senior developers, really they can start playing around right away with the documentation and they try things out. Now if you are not really a person of discovering new concept on your own, more especially from a documentation can be entirely really scary. So you can start a video, because in a video someone is going to break down the important concepts and actually share them right away. So learn just language basics, okay, from a tutorial. The way you're watching this tutorial, this is the first step you're supposed to do. Learn the basics and don't start right away doing projects. People normally say start doing a project. I don't think it is right. Just simply learn the basics. I mean, like the syntax. How do they write this? How is that? So learn the basic syntax and some of the small concepts in the basics following a video. Okay. And then I think just be patient. Just be patient with yourself. Simply just go through the learning process. It can take about only like 1 week or 2 weeks to actually finish all these steps. So the second one is try small basic challenges like on your own. So as you're just learning, watching the basics from a tutorial. Now if the tutorial has some exercises that are well and good, but if you just learn, these days you can get challenges from ChatGPT, you can get challenges from online. Just generate basically small challenges that you can try on, and you can simply go to and say, for instance, you're learning TypeScript, you can just say TypeScript basics exercises, and they will give you some exercises that you can create on your own. Now likely in some of these things I have a documentation whereby we'll be even also sharing the exercises as we move on. So try some basic challenges on your own, small ones actually. Don't just do very complicated things. Simply do some things on your own to make sure that you understood the basics. So when that one is done, still go back to wherever, YouTube or anywhere, or into a course. Okay, so learn advanced concept following a tutorial again. This can be from YouTube or from a course you bought. So you can just simply bought a course, like the way you're just going to do a new Next.js full stack course using TypeScript. You can simply buy that course, and then you have everything you're just talking about here in one place. So you just learn like the concepts, just the advanced concepts, and this is just looking at maybe use cases and the most common use cases of that basics that you are learning. Okay, then go ahead and build at least 2 big projects, and simply just for a tutorial. And this don't mind that those people say right away start doing a project on your own, but really you're going to actually learn the concepts, and then you have to really build at least 2 projects or 1 project following a tutorial, seeing how he or she is putting those concepts in real production apps. So just to really see how it is putting this, how is maybe the structure of the app and everything, how it goes. Then after that, at least start now building some projects on your own. And this is the part people always stick to this number 4, whereby they keep on watching more videos. They become 100, they finish 1 month, 2 months, 3 months, and 5 months, 6 months, and they're still watching the videos and they're not getting the concept. Really, what you have to trust yourself is that you have learned some things. Now it's time beautiful to build the projects. Now don't be attempted to build projects which are on YouTube. Simply build concepts that are on your own. This you can go on ChatGPT and get very unique problems that you can implement. Okay, so having said that, at the end of the day, if you follow those steps, you'll find that you just wrote a lot of code. So in that span of the time, let's say it is 2 months or 1 month you took to learn all these things, you'll find at least you have learned or you have written a lot of code. And that's what is most important at the end of the day when you're learning a new language. What is most important is to make sure you write code on a daily basis. As you keep on writing code, things become more simpler as you go on. Okay, so let's start with what is TypeScript. Okay, so you have just looked at the introduction. I've hyped you, I've given you the vibe. At least at this point, you should be eager to learn TypeScript, because I've seen it is one of the important to add in your stack as a full stack developer or a front-end developer. You really need TypeScript. So let's start with the basics and understanding, and I just hope that as you are just watching, please have a pen and a book. And you don't even need, in this first time you're watching this video, you don't even need to open your laptop. Right out that yes, having a pen and a book, this is very important, so that you just be looking at the concepts and you note them down. Okay, so let's start with understanding what is TypeScript. Okay, at least the most 3 asked questions people ask is what is TypeScript, why do you need it, and how is it different from JavaScript. So let's start with the simple one. What is TypeScript? TypeScript, as we said, is a programming language created at Microsoft to address shortcomings of JavaScript. So as JavaScript was so nice and everyone was using it, so as we kept using JavaScript over time, problems and started manifesting in JavaScript, more especially on how it does its things. Okay, and Microsoft sat down and they created another language called TypeScript to actually address JavaScript, like maybe to make it more smarter and even more nice. Okay, so to understand this, the original JavaScript and TypeScript, just look at them as 2 kids who are actually brothers. Okay, so JavaScript is just this kid without a discipline who does whatever he wants. Okay, at least this is somehow true, by the way. Like JavaScript somehow so messy, like you do anything and it goes. You're going to see in a second. You can just simply write anything and most of it will actually go, even when it is not true or it is really doesn't make sense. It simply do it. So JavaScript is just like this messy kid that does this, and then TypeScript is this kid who is disciplined and he actually very smart and he keeps everything precise concept, and really you need to be this smart kid rather than this non-disciplined kid. And this is just an analogy just to make you understand what JavaScript and TypeScript are. They are simply brothers, but TypeScript is more disciplined and JavaScript is just like so much messed up. You write a lot of things that go on and then they screw you later on as you're doing production or as you're writing more code. So having said that, we can just like look at JavaScript weird behaviors. For instance, can you imagine you can just say 2 + 2 and you get 22, because we know very well that you are adding a string here and it's just going to simply just convert and you're having like 22. How is that even possible? Okay, and that is our JavaScript. Like you can have something like this going on, which will never allow you to do in TypeScript. Okay, so basically or technically TypeScript is built on top of JavaScript. So basically every JavaScript file you write is actually by TypeScript. Like they have in TypeScript, they have everything JavaScript does, plus now they start typing, or you're going to see it adds in more things in the original JavaScript, but it doesn't actually just say it is adding any more logic. It is not adding any logic to JavaScript. Okay, there is no any big logic they add in JavaScript. It just simply changes how you do things. Okay, but it doesn't add more logic. So what does exactly TypeScript do in a project? Okay, so TypeScript do only one big thing in the project or in your JavaScript project. What it does, it adds in what you call static checking. That is the most biggest advantage or the reason why everyone is moving TypeScript. It is just because of only this reason. Static checking. At least there are some other ones, as you can see on the side below. I've added the code completion, refactoring, and shorthand. Those ones just come in hand later on. But the most big advantage of TypeScript is actually static checking. So what is static checking? So if you look at static checking, basically, if you want to understand static checking, you have to first understand the two things: dynamically typed languages and statically typed languages. So in dynamically typed languages like Python, JavaScript, PHP, Ruby, those ones are called dynamically typed languages. So dynamically typed languages, these are languages whereby when you define variables or data types, the language is going to try to guess the data that you have saved in a variable using just like by default they will be guessing whatever you save in there. Okay, so they keep on guessing and then allow you to do anything. Like if you just say, for instance, let age is equal to 20, at that point they guess that you are trying to make it a number. Then later on you change it to John, and then they can actually they just give you freedom to change it to John because they know that's what you want. Okay, so there's a lot of freedom in dynamically typed languages, which this freedom later on becomes a problem. Okay, as the code goes on and is big, some of the things you define, you forget them. Okay, so this can become or can lead to bugs. As you can see here, you have age is equal to 20, and you came here and you named it as John. Later on, you're trying to do math.round age. You then fall into problems in production. Okay, so the problem is that we can't catch the bugs until the runtime. At least you can't see it that it's going to happen. You keep on with the clean code as you're typing it in your VS Code. Later on, when you just deploy it online, then it gives you the errors, and you couldn't capture those errors as you are writing the code, and that is a big problem. Okay, and this is what the actual problem TypeScript is trying to solve, that this bug would have been captured while you are typing it in locally or in your VS Code as you are still writing the code. You would have captured that bug, but here in dynamically typed languages, you can't capture the bug until the production time. Like you keep on doing until you reach production is when you're going to see the error. Okay, not in the runtime. So not so in real writing or in just as you type. So, but statically typed languages like C++, C#, Java, and I think that's why everyone always say first learn C#, Java, or any OOP language at the beginning. I don't think like static typing is easy. It is not easy. That's why most people will start with Java, C++. Others didn't become developers. Those who became developers became good developers, but most of them don't even reach becoming developers because the language was hard. Others failed to comprehend and they didn't become developers. People who start from HTML, CSS, on the other hand, they end up becoming developers because really at the beginning you are starting and everything is easy. So statically typed languages are not just like they are easy, but as you have written a lot of JavaScript and already know some JavaScript, now it's time to move to statically typed language, like really to understand what is statically typed mean. So in static typing, they will be checking your code as you're writing it. For instance, if you define that the age is going to be an integer, they will be surprised if you come and say age is equal John. So they will not allow it, and right away, before even executing the code, they will tell this is not acceptable and we cannot allow you to continue. Now this can be just like you are writing within within prison, or you're writing very restricted mode, but actually it is something that is very useful. One, it makes you to have discipline, as we saw here. TypeScript is a disciplined code. Being disciplined actually means that you have to follow certain rules. You can't accept to mess up in areas, in some areas. You have to follow a set of rules that makes you actually disciplined. That's what disciplined people mean. Being disciplined is really following very strict rules to do some routine tasks. For instance, if you say you wake up at 4, it might not be very easy, but that is your discipline. You must do it. And this is the same thing here. When you're doing static checking, you must be disciplined, as in you have to follow certain rules and regulations. So, understanding what is static checking. Static checking refers to the process of examining code for errors without actually executing the program. Now, this concept have been there, but wasn't in JavaScript until they brought in TypeScript. So TypeScript is simply doing this one big thing: static checking. Simply checking for errors as you are continuing to write your code. Okay? So basically, at the end, TypeScript is JavaScript with simply type checking or static checking. So for instance, in TypeScript, you would select x is equal number, and you say is equal 10. If you try to say x is equal a, they will be surprised. Okay? Right away, you can see x has a squiggly line below it saying, what the heck are you trying to do? You said x is a number and you're trying to put a string in it, and we cannot allow you to do that. And that's the discipline we are talking about. It is going to actually keep on telling you and not allowing you to mess up all the time. Okay? So one thing you have to understand about TypeScript is that it cannot run in the browser directly, so it needs a compiler. So as you know, TypeScript is simply just like in between to give us static checking, but you know very well the browser understands only 3 languages: HTML, CSS, and JavaScript, not TypeScript. So TypeScript has actually to be compiled. Okay? Like it has you write your TypeScript code, then it has to run through a TypeScript compiler, and it will compile all your code back to JavaScript, meaning that TypeScript is just there only to discipline us as we are writing our JavaScript. That's the only thing it does. You're going to see you do the same logic in JavaScript. The whole logic remains exactly the same. The only thing that changes actually is simply the discipline that they actually make you do as you're writing your code. The first discipline is that you are going to define all the types. You define what is this, how it's supposed to behave, so that they understand how it should be treated to avoid you making errors in the future. Okay, so as we've seen, some of the benefits of TypeScript. The first one, as you said, is static checking. Checking for errors as you're writing code. That is the most biggest advantage or benefit of TypeScript, static checking. Another one is code completion. So as you have already told it what is stored in a variable, it actually knows it in memory. So as you are trying to write, it actually is going to be helping you, telling you exactly what you have already written. For instance, if you have a user and you have defined some data on it, it's going to be remembering and it's going to be giving you code completion. Refactoring, it can refactor your code, and you find that you're just having a well-documented code. Okay? Shorthand notations, you're going to look at that as we move on. TypeScript drawbacks. The first one is that since TypeScript cannot be run in the browser, it has to run a step of compilation. it has to be compiled from TypeScript back to JavaScript, which actually takes some time. Now, it might not be noticeable, but just know JavaScript is more faster than TypeScript itself. So it has to run that a second step to compile back TypeScript. Now, that is really not something which is noticeable. As you're typing, you not even notice that it is being compiled. So discipline in code writing, as we said, discipline at first you may think is easy. Being disciplined is one of the hardest things. At least to me, this is one thing I always try to always follow, to be a disciplined person. I think even life, everyone is struggling with being disciplined. You tell yourself, I'm going to do A, B, C, D, and you end up not following it. And that is not being disciplined. So discipline in code writing is a drawback, because it's not something which is out of the box very easy for many people. Following rules and regulations, most people don't actually do that. But as we keep on writing the code, this whole thing of discipline comes into you to define types and follow the standards. Okay? So when to use TypeScript and when to use TypeScript. Now, if you have a small project, for instance, you are trying out something small, or it's just like a simple project you are trying to do. Maybe it is only like some button increasing something. Really, you don't need to use TypeScript. TypeScript is supposed to be used in medium to large projects, okay? Because really it will be an overkill if you had a very small project and you're using TypeScript. But of course, as life goes on, as you keep writing, you'll find that you are defaulting back to TypeScript. And everything you are doing, any next project you are doing, you are using TypeScript. Because at the end of the day, it can be a small project, but will end up being a big project in the long run. You may start something very small, you are joking with it, but later on, it becomes a big project. Really, so you have to determine and know that, is this a project I'm going to be serious with? And later on, you have to switch to TypeScript. So you might find that you are actually doing even small projects, you're using TypeScript. But in some cases or some scenarios, you can use simple projects, you simply use JavaScript. And then in a medium to large projects, you use TypeScript. Okay? So what do you need to know for you to actually do TypeScript? So as you know that TypeScript is simply all the JavaScript now with added type checking. You simply need to know only concepts of JavaScript, really basic concepts like variables, arrays, object functions, destructuring, and even all those basic things that we have been doing in JavaScript. You simply need to know some JavaScript, and that's why we actually recommend that before you do TypeScript, at least first do JavaScript. You can't just simply jump into TypeScript before doing any JavaScript. So first do some, at least you know some JavaScript. And if you're watching this video, basically, I know you are very okay with basic types JavaScript. At least if you are doing Next.js, you have reached that time of doing Next.js, you already have some basics of JavaScript. So you're just going to right away to go to installation. Now, we're also going to look at installation via Next.js and others. But what I just want to give you the tip is in the next things we are going to do. So we have been going through slides and we are going to start implementing things with code. Okay? So the first tip is that make sure you watch all the episodes or you watch all the things. And if you don't understand any part, please rewind back or simply just rewatch the video to understand the concept and simply make sure you are taking notes. Okay? Make sure you have your book and a pen and you are taking notes at this point. Okay, if there are some exercises I'm just going to provide you, please do all the exercises. Okay, so what we're just going to do is getting started, and in this course we have structured, as we are getting started with this, I've structured this into three parts. The first part you're going to look at, maybe in this episode we are watching right now, we're just going to do TypeScript for beginners, and this is what I was talking about. Just learning the basics. How does the language work and the basics I need to know. And in these basics, we're going to look at all the concepts, how to define things, how to use it in Next.js, and so on and so forth. Then in the second part of the course, we're just going to look at TypeScript in Next.js. And this is really looking at really use cases. How do you really use it in the program? Like, at the usage level. Like if you're doing a normal project, how are you going to use it in real life, and what are the most used cases of using TypeScript in Next.js. And then the third part, which is actually TypeScript in production, really building an actual SaaS app or building a full stack app using TypeScript. Okay, so and from this tutorial, if you have watched this, you are going to check that on my YouTube, we are going to move right away up to TypeScript, and everything you're going to be doing right now is going to be in TypeScript. Since we have now this video on, you can always rewatch it so that you are okay with the TypeScript basics, and then later on you can move on to the advanced concept, like building the projects. I will always be referring to this video as we are building bigger projects. I'll be referring people to come back to this site and learn the basics. Okay, so these are the basically how we are going to structure this. So and this episode or this video is part of the bigger course. The bigger course that I've been talking about, I was going to release it using JavaScript. I had to wait until we release TypeScript so that we actually build everything in TypeScript. Now, by the time you're watching this video, maybe the course is very complete. You can check the link in the description. If you find the link is not there, just know the course maybe is not there, is not there yet. But at least you'll find there the waiting list. Join the waiting list for the course. Anytime is going to land as we're doing this. And in that course, you're going to do big projects, 4 big projects, and you're going to find the course description and the link to the course page. You're going to find everything in the description. Go to the course detail, look at the 4 big projects you are going to build, including the bank app, medical app, and portfolio app, and even a job portal, and even other projects that are going to be just added in that. I believe in redoing full stack projects so that you can actually understand the ins and the outs of a language. Okay, so this is to tell you that this is going to be part of the big course. As you're watching this, just know there is more content to learn after this, and to know how you can use it in really production apps. So everything you're just going to be learning in this video is going to be fully documented, and I've been working so hard to make sure that we have a new documentation working so that we'll be using everything we are learning. You have a cheat sheet, you have a point of reference. As you know, in most of my videos, I've been using Notion. Now, most people tell me the experience with Notion is not so good. So I went ahead and I built the documentation that we are going to be using in all our video tutorials, in the courses, and even so many things. We'll be using this documentation. So let's just go and head to the documentation, and I show you how this documentation looks like and what you expect out of it. So moving here in the browser, I'm just going to go here, and I'm just going to put this link to the documentation. I will put it in the description. Just find that link there, click on it, and you'll be on this documentation. Now this documentation is going to be helping us in so many ways and in different areas. That's why I took my time to start working on it. Now at this point you're watching this video, maybe it is complete, maybe it is not. If you're just watching of this video and the video just simply like in 1 month, or this is not yet done, as you can see, it has a lot of things on it, including like the roadmaps to help you in what to learn for each things. So you have roadmaps, we have the lessons, tutorials for each HTML, CSS, JavaScript, Next.js, and so many things. YouTube video tutorials, each of my YouTube video tutorials, they are going to be having documentations. Okay, the website templates, we are actually launching a template site whereby you can buy templates and also use some of our free components. I'm just going to be launching it soon. Even all those ones are going to be having the guides, how to use any of those templates you are buying. We are going to have the guides on this. Then the course guides, as you are seeing the full stack course, the one you're just going to do the Next.js full stack course, all its guide is going to be in here. Okay, Then we have so the courses, they are going to be in here. The course code snippets, as we're just going to learn things, we'll be putting most important snippets around here. We have interviews and so many others that we're going to be doing. Now at this point of time, I've just started this. I spent about like 1 week working on this, and I came up to this point, so I'm still working on it. And what I've managed to work on right now is this thing, Typescript. The fact that we're starting with Typescript when this documentation is being made, that's why I'm actually just having the first one as Typescript. So just come here, you just click on the first link which says Typescript in Next.js. Simply click on this one, and you're just going to be headed to this documentation. Now, me personally, I've been looking for looking around. You can open thousands and thousands of documentation about Typescript and Next.js, or Typescript to React, or Typescript basics. You'll find it is not easy. You find everyone is explaining their own concept in the direction they want. Okay, I tried to use this as really a learner's guide, because I was a person who was trying to learn Typescript and the whole pieces were scattered over the place. I tried to put all the pieces together you need so that you have everything in one place. Okay, so we're just going to start with Typescript for beginners, whereby you're just going to look at the basics, and then we keep on advancing to actually to bigger concepts or the harder concepts. Okay, so at first is understanding what is Typescript. At least we have looked at that, and we have all accepted Typescript is a superset of JavaScript that simply adds the static typing or static checking to your project. This means you can define data types for variables, functions, and other constructs, improving code clarity, maintainability, and catching errors area. At least we have talked about that in a few seconds earlier. We have talked about what Typescript is and why is it, and we said the biggest thing is you can do static checking, and which will help you to catch errors as you code. So the benefits of Typescript, as you can see, the first one is to catch errors and improve code navigation. You're going to see that most of these code editors like VS Code, they are going to help you in auto completion. You're going to be understanding how nice that one is. Then large projects, you better structure and you are enforcing solid principles. You can search about the solid principles and understand what is solid principles. Okay, then better documentation. So as you're writing these types, you are documenting your code. Okay, so you can just go ahead and read about why you Typescript, but of course one thing I've already said about why you should learn Typescript in this 2024 or even these years, if you have watched this later on, is that it is growing in popularity. The fact that everyone in the React world or the React community, everyone is learning Typescript or is knowing Typescript, definitely you'll be forced to actually know or understand how to use Typescript. So at least learning it as early as possible is another advantage. So the first big thing you're going to look at is how to install Typescript in a Next.js project. Okay, so if you go to Next.js documentation, they provide Typescript fast development experience, at least from the last keynote, and even when they brought Next 13, the first thing they actually worked on is making Next.js Typescript fast development experience. At least they are thinking of 21st century web developer. You should know Typescript, and they are defaulting to Typescript in everything they are doing. Even the documentation, they hope that you're using Typescript. Okay, so that means Next.js now ships with Typescript, ESLint, Tailwind configuration by default. All these configuration for Typescript, ESLint, and Tailwind, they come on default. You don't need just to pass even a tag of dash Typescript, because by default they will give you the prompt of adding Typescript. So basically open your terminal and write npx next app at latest. So when you run this one, of course you can go here, and then after running that, it will be prompted with some questions, and one of the thing is TypeScript. Okay, so you can see they will ask you TypeScript to choose whether a no or yes. Please just simply move the arrow to yes, and make sure this time you actually install TypeScript. You can see I took my screenshot of how I installed mine. This is the questions I'm going to ask you. Would you like to use TypeScript? So you can see the command I created, npx create next app at latest, and then you give the name of the folder you want to create. TypeScript for beginners is the name of the project, and then they will ask you these questions. And the first one is actually, do you want to use TypeScript? Simply say yes, and also say yes to ESLint, say yes Tailwind, say no to source, or you can even say yes if you're just a fan of using the source directory. Me, I don't normally use it. Go ahead and also app router, yes, and just like that, you have your project initialized. As simple as that, you have TypeScript added to your project. Okay, so the first concept you have to learn is actually what we call TypeScript inference. By the way, I went ahead and spinned my project. So this is the project I'm having here. You can see the first thing after you have installed your project, the first thing you notice is that, let me zoom in a little bit, is you notice that everything right now is using TSX. Okay, so TSX is a replacement for JSX. T for TypeScript. Okay, so we have been writing JSX for JavaScript. Right now we write TSX for TypeScript. So whatever you have, for instance, like tailwind.js, you see it becomes .ts, and whatever you're just going to create a new function, maybe a new file which needs TypeScript, you just name it as TS or TSX if it's going to render some HTML. Okay, so that is the first change. And really don't have to get scared that the app is going to become complicated. No, you can see right now after running this, let me just go back to the size of the screen. Most people always really find it. So you can see here in this, I have just as normal JSX, the one we have been using, the way we have been using. You see there's nothing that have changed. Okay, there is nothing you need to worry about at this point. When you just install a TypeScript project, Next.js project, really there is no big deal to worry about, because at first don't worry in implementing more of TypeScript. Simply write, you just say, I'm just going to write the TypeScript I know. Okay, then whenever I get errors, I make some research to rectify it. As simple as that. That's how I learned it. So you can see I have just removed all the code that was there in the main, and then I placed it on this div with h2 saying TypeScript for beginners. Okay, so if I just go back here, the first concept you are going to start with is TypeScript inference. Okay, so TypeScript as a superset of JavaScript, it gives you start typing, and we have talked about this. So TypeScript is really smart enough to understand some things already. You don't need to start like fearing, I have to define everything and what. No. So TypeScript inference is TypeScript using its intelligence, or being smart enough to know the types you are saving in variables as you are writing them. So this means that it can automatically deduce the type of variables, functions, and other constructs based on their usage. So they look at how you're using it, and they actually know what type of variables or what types you have saved in that. So you don't need to really worry about that you're going to be defining everything. Some of the things you don't need to define them. TypeScript is smart enough to know that you have said this, and it's automatically. So to give you an example, for instance, we have here some examples. Okay, let me just go here. and I'll just give you example. So if you say const, if you just say const, for instance, age, okay, is equal 20, okay, you just realize there is no any errors at this point, and this is normal JavaScript. I've not written any TypeScript yet. I've just written just JavaScript. Let me just create others. Const, for instance, const first name is equal to JB web developer. Okay, I can just define this, and you see there is no any errors. I can just go and say another, maybe a boolean, const is verified, okay, and is equal to false, and you see there is no any errors. Okay, so this TypeScript at this point, some things which are simple like this, naming variables in normal circumstances, it does not even require you to actually write TypeScript, okay, to define this, because it is smart enough to know that age, if now I hover here on age, here you will see that, okay, age here, you're going to say that age is of type number, okay. And if you just want to know how it is doing this, let's just say here, actually just change this to late. So let me just change this to late, so that we just try to change them, late and also late, okay. So let me just say, for instance, age is equal to John, okay. So if you do this, you check, if you say John, age is equal to John, is going to actually align this, and it's saying type string is not assignable to type number. And just because after you named this, you can see when you select age is equal to this, you can see by default it is already knowing that age is a number, and we didn't define anywhere number. So this is what you call type inference. It is inferring to this, or it is smartly seeing what you saved in this, and it knows that this is a number, and right away it cannot allow you to do this. Now in normal JavaScript, this would pass, okay, this would pass. It would allow you to name this to John, and it would go on. If I just go here and I just say first name, and I say is equal to 3000, already is going to underline this, and it tells you type number is not assignable to string. Already it is smart enough to know that you initialize this as a string. As you can see when I hover here, it tells you first name is a string, and it knows this. And for this case, if I just come here and I say is verified, and I try to change this to something else, for instance to also maybe to true, okay, as a string, okay, just like this, maybe for God, and you wrote this as a string, and this is a common mistake where you're supposed to write true and write true as a string. Now you can see here is saying your type string is not assigned to type boolean, okay. So already it is already doing the type checking right away, minus even defining this, and this is what you call type inference, okay. So here just going to say TypeScript inference. So this is the first concept you really need to understand, that sometimes you don't need to define the data types. It will automatically set types as you just named them, okay. So to solve these problems, of course, I'm just going to go ahead and comment this to help you understand what we are talking about, okay. So the first thing is type inference. It can predict the type you are saving in right away, just like that, okay. So that is the first concept, and you can just go and read about the benefits of type inference and the limitations. Let's start with now really types. So as we have already seen is that for booleans, So apart from this type inference, you can now define types. Okay, so you can just say here TypeScript basic types, TypeScript basic, okay, data types. So we know we have the primitives, and the first one is, for instance, a boolean. So you can just say late, or you can just say const whatever, for instance, is married. Okay, and then you can just go and say this is a boolean. Okay, you can say this is a boolean, and then you go ahead and initialize it with a value, and you say true. Okay, so this is the normal way of defining actually a data type in TypeScript. You use this colon here to actually define the type that is stored in this variable. Now, this is how it would be stored in normal JavaScript. We say let is married is equal to true. So we know this. Now to bring in TypeScript to do this, you simply actually add this colon in front of the variable name. Okay, you go to the in front of a variable name and then add this boolean. Okay, of course in this case the data type. So this can be done to a number. Okay, so you can just select price. Okay, and you say this is going to be a number, and then you say 2,000 or 3,000. This can be also be done to a string, and you say late full name. Okay, full name, which is going to be a string, so just a string, just like that, and then you give it a value which is going to be maybe this. Okay, so you can see you have, this is a normal way of defining the data types. You just simply give a variable, then in front of it you actually give it the type. Okay, and you don't need even to initialize it. You can still actually define and then initialize later, like give it a value later. Okay, for instance, you can select color, and you say this is going to be a string, and then you just leave it at that, and then you can just come later alone and you say color is equal to blue, and this is very okay because you can see color is equal to string. Okay, you can first define it outside here and later on give it a value, or you can just give it a type and give it, initialize it with a value right away. Okay, now in most cases this is not required because already, as we have already seen, type inference can actually cover that. So in normal circumstances we are not going to be doing this unless otherwise. Okay, this is to show you how you would define it if you want to explicitly define it on your own, but since it is using type inference, I don't need to do these simple variables just like this. Okay, moving on. So you have seen the boolean, numbers, and strings. This is how you define them. Okay, so let's start with the one which is like taking it one more step further, arrays. Okay, so if you're just going to have arrays, so let me just put here arrays. So for arrays, if for instance we have const and you have const maybe names, okay, so you can go ahead and define this. Okay, and this is going to be maybe strings. Okay, it's going to be a string, and utate is going to be array of strings, and this is how you can actually define it. And you can see, for instance, JB, you can just go ahead and you put Sam, you can just go ahead and you put maybe Owen, Joel. Okay, so you can just have the names, and this is how you define it. The one thing is that the name of the array is names. In front of it we define a data type like this. So an array is denoted by this square brackets. So you put the data type like this, like string, and then you tell it that is going to be an array of strings. Okay. In a similar way, we can say, for instance, const numbers. Okay, for instance, you can say const numbers, just like this, and here you can just say, of course, is of type number. In fact, just name this as prices, and then you can just say this is going to be of type number, but it is actually an array of numbers. Okay, and then you can just go ahead here and you say, for instance, 3,000, 2,000, 1,000, and so on and so forth. Now, if you want to see TypeScript in work, for instance, while we have this one, let's just come here and do something like this. Okay, so if you just came here and you forgot and you put one more thing, for instance, 500, okay, or they are going to underline this and they say type number is not assignable to type string, because you have said this array is going to be for strings. Okay, so you can't put in 500 inside here. And this can also, a live example would be if you attempt to do, for instance, names dot push. Okay, so you, of course you can see here already, if I say name dot push, the first error they tell you that property push does not exist on void. This is not there, so just say names dot, and look at this. If you say names dot, this is what we're talking about. It is giving us now code compression, like all these methods, because all this is, it is an array. So just say push, and I'm also going to push 300, and look at this. I'm trying to push 300 and it tells you argument type number is not assignable to parameter type string. So you are trying to push in this, you are trying to push the number, but you actually define that it is an array of strings alone. So this is really helpful, and it will not allow you to go. Okay, so it will not allow you to do those kind of mistakes. There's similarly, if you just go here and you're trying to say that prices dot, and you say dot push, for instance, and you're pushing a string, and you say maybe 300. You're trying to push in anything which is a string, so you can see here that it's going to tell you type string is not assignable to parameter of type number. Okay, so this is how TypeScript starts actually to help us to capture the errors that we might be actually attempting to make. Okay, so now as you can see on the arrays, I give a number of examples and so on and so forth. Now what you should know, there are some other types of arrays. Okay, and basically there's one array called tuples. Okay, so there's one we call tuples, and the tuples has a fixed length with a specific element type at each position. Okay, so for instance, you can just go and say const, okay, maybe const, as you say, maybe person, and you can go and say this is going to be a specific array, and you say maybe at first it has a string number string. Okay, if you just do something like this, you are trying to actually define an array, first of all, of 3 items. So that's to say a fixed length. So if you just a string number string, that means the array first of all should only have 3 items, and the first item will always be the string, the second one a number, and the third one is string. So basically, if I go back here and I try to define here like 300 comma, already it is going to give you it's saying type number inside the type string. They are saying you're supposed to put a string. So let me just go ahead and put here John, and then here number, now you can put 300, and then string you can put Joshua. Okay, just like this. Okay, so this is called a tuple. So this is called a tuple. So a tuple is an array of fixed length and specific. So this has a fixed length, okay, and specific data types at different position, or at each position. So you can see on each position we have actually a specific data type, okay? That's what you call a tuple. So of course all this is documented. You can just like play around and see all this. So the next is a function, okay? So of course we are looking at basics, guys. So next is functions. So let's say we have actually a normal function. I'm just going to say function, okay, maybe sum, and this function takes in a and b, okay. Maybe you could just even say num1 and num2, whatever you want to do, but just like there are two numbers, and maybe here just say return num1 plus num2. So this is typically the way you would implement it in JavaScript, okay. So let's look at the first problem we get, okay. So the first problem is, you see we have a num1 here and num2 here, having saying that num1 implicit has any type, okay. So just going to look at what is this any type, okay. So maybe I could talk about the any type now that we're just seeing this this thing here. What this means, the any type. So let's just look at the any type. The any type. So the any type, as you can hear, this is the default behavior of a variable if it has no any types on it, okay. So this is like any type is just like normal JavaScript, and you could just come here and click on any type. It is just here, okay. So the TypeScript defaults to any type if no type is specified, allowing any value to go or to use any value. Basically, this basically means writing in normal JavaScript. So if you want to write in normal JavaScript, as you can hear, this is normal JavaScript. These ones are having the any type, okay. So by default, if you don't give any type, it's going to take the any type. And what I mean that any type, anything can go, anything can be done, okay. For instance, these ones are numbers, but if you just came and say num1 dot, first of all, you can't get autocomplete. They don't know what this is. So if you just try to say, for instance, dot to uppercase, just like this, okay. So you can see there is no any problem, but we know num1 is a number, but we're just trying even to do uppercase, which is a string method. Already this is an error. So the any type, you should avoid it at all cases, guys. You should avoid using the any, and you can even implicitly say any, just like this, to take off these squiggly lines. You can see any, just like this. But what basically means that you don't know the type of this, okay. You don't know. So you're saying this can be any type, okay. Like this can be any that type, boolean, string, anything goes. And you can see here you have n1 to uppercase. This one is not having any problem right now, but we know that this one is supposed to be a number. So for instance, if I come here and I say number, then this one is supposed to be a number. Already automatically the error will be captured here, that you are trying to get a number and you are writing to uppercase. To uppercase does not exist on type number, okay. Look at that, guys. Look at that. So they're just like helping you to capture that, and you don't have to mess up. The same thing now, any2, if I just change this to any2, since this any goes, it is going to allow anything. But if I just say maybe this one is a boolean, they will tell you. You can even see the addition here, they captured. Okay, you can't do this. They're like, are you trying to add now a number with a boolean even here? So they will capture all these errors automatically for you and don't have to wait until you reach production. Anyways, let's just also give this one as a number. Okay, now to uppercase is of course quote. Now we can remove this one, and you can see basically here you have now any1 and any2. Okay, and this is really now okay, has no any issues. Okay, now in the functions, all the arguments you pass in here, they must be actually having the all your parameters must be given types like so. Okay, for instance this one, now this one is okay. Now one more thing with functions is that there is a lot of type in inference. For instance, when you put in like this one, the Typescript is going to predict what is going to be the outcome of this function. And if you want to hover, you can hover here. Okay, and you can see that it is saying function sum, it has num1, num2, and look at this, is putting dot dot and is saying it's going to give an output of a number. Okay, because to know you are doing the addition here, whatever you're going to return is going to be a number. So you could define here and you say that the output is going to be a number. So this is the fully way of writing the function. You must give the parameters, you must define the types for the parameters, and even the output of the function you can give it what is going to be output. But most times we don't actually do that, because the Typescript is going to look at what you are implementing and it will see what you are actually doing. Okay, it will know that it is returning this. Okay, so for instance, if I just come here and I say const sum is equal to num1 plus num2, and then let's just say return. Okay, I'm just going to return a string and say the sum is $sum. Okay, so if I do this, so what happens? First of all, it is telling you here a string is not assignable to type number, because you said you should return a number, but surprisingly you are trying to return a string. So it is actually on you. And by the way, now if you do this, okay, you see the problem is gone. And if you now hover one more time on the sum, you can see that telling that you are adding the two numbers and the outcome is a string. Okay, so here they use type inference. You don't actually need to define what is going to be returned here. Automatically is going to see on your return and will suggest what return type of the function is going to be. But the only important thing is actually to name these ones. Okay, so those are the functions. So let's just go back of course here on functions. Okay, now one thing is the void. Now really void is not so much as a data type, but actually something we use most in Typescript. And this is if it is a return type, you can see, represents the absence of a value, often used for functions that don't return anything. So if you had a function, for instance, okay, greet, just like this, and then it is just simply saying console.log, okay, and it's saying console.log hello world, just like that. So this function here is returning nothing. Let's hover on it. So if you see here, greet is declared but never used, and you can see function greet and it returns void. So what it means, it is returning nothing. Okay, it is returning no any value. It is returning, and that's what you normally term as void. Okay, so you see we have a function here and they gave it here void. it could even just like say, we can just say message, okay, and then we say this is going to be a string, and then if you just say already console.log, of course, like message, just like this. Now still this is going to be giving void, now that you are not giving it, but of course you would go ahead and give void as the return type by yourself. But as I've said, the TypeScript is smart enough to say that you are not returning anything, and it will assign this to void. Okay, so moving on to enums. Okay, so now enum actually is one of the weird parts of TypeScript. Like, what you think they do in the first place, you'll be surprised. Okay, so for instance, enum is a special class that represents a group of constants, okay, and unchangeable variables. Enums come into two flavors, the string ones and the numeric. So let's start with the numeric ones. Okay, so for instance, you might be having something like this. Let me just zoom in a little bit. So you might just be having something like this. Okay, so you have like enum, and you have the coordinates or the cardinal directions. You have north, east, south, west. Okay, if you look at it, it looks like you are creating an object, but really actually is not an object. The fact that it has this keyword enum, okay, so you pass the word key enum and you pass in all your things you want to store in. Surprisingly, if you define something like this, let's go ahead and do here console.log. Just going to copy this to give you some surprise. I'm just going to go down here. We'll go back to any, by the way. Let me just say enum. Okay, let's just paste this here. Now, if you have this, now to simplify life, I'm just going to make this. Let me just make this use client, so that we just be looking at this in the browser. So let me just go here in the browser, just like this. Okay, just bring this here, and let's go to the console, and let's just refresh. Okay, let's just go down here. So we have here read this. So let's just go ahead and do a console.log. So just say console.log current direction. Okay, so if you just do current direction, we have current direction is, they have the cardinal coordinate, cardinal directions. Current direction is cardinal direction dot north. Okay, let's just go ahead and console.log current direction. Look at that, guys. So we have 0. So what the heck is this 0? Okay, because even me at first, I couldn't understand. Like, I thought I have like these choices, like if I just say north, then it's just north. It turns out these are just like variables. They store some values in it. So this, by default, when you create an enum, it starts from 0. This one, it will give it a value of 0, value of 1, 2, 3. And I wrote it here in the documentation that enums here, down, I think I just defined it here, that you will see that, for instance, if you just get 0, it's just because enums, you see here, by default, enums will initialize the first value to 0 and 1 to each additional value. So this is 0, 1, 2, 3. So what enum uses is actually to store some values in things. Okay, so you can store some values. Of course, you can go ahead and change the order. For instance, I can say equal to 1, okay, to the first one, just like this. Now if we just go is to east, if I change the current direction to east, now that I've changed the direction to start from 1, so by default it will start from 0. If you want it to start from 1, you come and you go to the first one and give it 1. Now if I just say to east, so this one should give us 2, hopefully. So now you can see here we have 2. Okay, so this one taking it 1, 2, 3, 4. Okay, so one more thing you can do with them is that, of course, you can see here I changed it to 1. Now one thing, you can just also give them different values. Okay, you don't need just like see, so by default if you just only say 1, it will just say 2, 3, 4. But of course you could even just go ahead and say, for instance, different things the way you hear status codes here. Let's just copy this example. By the way, you can just come here and you can simply do, for instance, enum status codes, and you can say not found. Success, you give it different status codes, and now you can just go here, for instance, status code dot not found. So you can see this is a good use case whereby you can store some things like this, like status codes. You can just store them just like this, and you can access, like for instance, 404 by accessing status code by not found. Okay, great. So these are the enums. You can also go ahead and store strings, not necessarily you store things. So how I look at enums is like a way of storing values, okay, but not in the object way, because this looks like an object, okay, but this one is just like that. You don't have so many methods. You simply have, like, you can store values just like this. Speaking of which, let's talk about objects. Okay, so of course we all know the normal JavaScript objects. So down here, I'm just going to go down here and I say objects, and in TypeScript, so we know you can just say const, you can say person. I don't know if we already have person somewhere, is equal to, and I think we already have person. It just says student. Okay, so you can have const student, and you can just go ahead and define things here. Okay, you can just go ahead and say student has a name which is John. Okay, has a name called John, and then maybe we say age, which is 30, and then is maybe is orphan, and we just say true. Okay, so this is a normal object, and surprisingly, as you can see, is not giving us any errors. Okay, why? It is using TypeScript inference. Okay, it knows the types for all these ones. If you look at the name, is a string. If you look at age, is a number. If you use orphan, is boolean. So by default, if you're creating an object, a simple one like this one, it is actually already knowing what to do. Of course, you can just go ahead and define what is this. Okay, as we know very well how to define this, you can see you always define this like this. Okay, the how we do our things in TypeScript, this is the syntax. So the syntax is that, okay, you have whatever you have, which is like a variable. So you say let variable give the data type, and then you can initialize it with a value. So this is the what you're supposed to follow as a syntax. You have the variable, then you give the type, and then you give a value. So the similar way here, we come to student, and then the first thing we add is a data type. So since this is an object, the data type is also in the object format. So you write an object and you say name is going to be a string, and you say age is going to be a number, and then you say is orphan is going to be a boolean. Okay, it's going to be a boolean. Now already, because of spelling mistakes, I want you to look at this. So I'm saying property is often boolean, and then look at this. Object title may only specify known properties, but is often does not exist on type this one. Okay, and this is like a common mistake whereby, like for instance, you are having things to do with typos. Like this is a simple typo which is really normally common. Look at the typo I made here. And TypeScript is very, very fast already knowing the error you created, because this, in unknown circumstance JavaScript, you will leave this and go. But it's telling you, you know what, this is not the same as this. Okay, so yes, of course, change this and we make it the same spelling, and now you are good to go. Okay, now the good thing with this, look at this. If I came and I added something else, so let's just say I forgot, and actually the common scenario would be, you can just say student, okay, dot course is equal to maybe computer science. Okay, you just do computer what, so you can just do those things, computer science. Already they will just give you an error, and they are telling you that the course does not exist on type this. They are showing you the type you have here. You have only the name, age, and orphan. This doesn't exist. Okay, now another thing that you're going to notice, if I just comment this, if I came here and added for instance comma, and I add course, okay, and I add course to be a string, okay, you see now we have another problem. So if you just hover here now, they will tell you that it is a property course is missing in the type string, like this. Okay, so here you said this object is going to have a course, but actually you don't have it. Okay, of course we could solve this by actually coming here and we add a course. Okay, and we add a course to computer science. We could do this and the problem is gone. Alternatively, we look at what you call options. Okay, so type option, you call them type optionals. I don't know if I just wrote about it. Let me just check here. Optional types. So let me just first go back. I don't think I talked about it. Option types. So just go and talk about it here. Option types. Option types. So option types is when sometimes you have, for instance, the way you are saying here, this object. So you can define an object, for instance, const user, and this user is going to be having, for instance, a name of string, okay, a phone of also maybe string, okay, and then we could just say also has maybe we could pass in that maybe the age, okay, and then we say age is a number, okay, and of course this one would go ahead and create an object of a user, and we could start with, for instance, name to Jane, okay, and then we go ahead and create the phone, which is a string, so I guess you can put 07 blah blah, and then finally you say a number, okay. So right now if I don't put a number, we want to make like a number to be optional, you will see that it is going to tell you there is a problem. More especially you can see here that the property age is missing, okay, because you defined 3 things in here, and then inside the initializing you only define 2. So to make this age optional, we use what you call this question mark. So you just come here and you say age is not required. And this is how you say that this is optional, by passing this question mark. So when you pass this question mark, it means that it can be null or undefined. So if you just hover now, it is not only just a number, okay, but now it's having undefined. And look at this, we're just going to look at this in a second, but it's showing you that it is now holding two things. It can be a number or undefined, meaning even if you don't put it here, later on you can put it, or it can fail to be there. And this is how you show the option types that are not a must to be used. And this is the same goes to the functions. For instance, you can define a function, and this function maybe is add, and is adding two numbers a and b, okay, just like this. And let's return, okay, let's return maybe a, just like this, for some reason. Now we can first say this is going to be a number, and so b is also a number, okay, b is a number. So you just try to call this function, and you say, for instance, add, and let's pass in only a, that may be 4. So if you pass in only one number here, you can see that telling you that it expected 2 arguments but got only 1 argument. Argument b for b was not provided. So you said the function is going to be taking in 2 numbers, a and b, but you didn't here provide this. Even when we are not using b here, it doesn't matter. But the fact that you specify that there are 2, you must pass 2 here. So this, you can come on this and also make it optional, just like that. Okay, so you can see b is optional, and you can see the error here has gone. And this is how you can use option types. Okay. Of course, as we said, type inference also works on objects. For instance, you cannot, even if you define it and you don't add anything, it already smart enough to know. Okay, if I say const maybe employee, okay, and I say is equal to ID of maybe 1 and name of John, okay, of John, it actually already knows this. Okay, it has already this. And if you just try to come here and you say employee, for instance, and you want to do things, for instance, dot, and you can see it gives you 2 options, name. If you just come here and you say, for instance, title, it is going to give you an error. For instance, here title is HR. So if you just try to do this, it is going to give you an error because it is already having type inference for this. Smartly knows this is an object with only 2 items, and this one is a string. This is a number, this is a string. As simple as that. So you can't do this already. It's smart enough to know even when you have not defined the stuff here. Okay. So moving on is the any type. So we said, I talked about the any type in just a few minutes back, and we said you can actually explicitly just say any. Let's just talk about it one more time. So down here, I'm just going to say the any type. What it means, anything goes. Okay, let's just say create another function, maybe let's just say say hi, say hi. So I'm just going to change this to this. Okay, so you can see here function say hi, it has a name, and this we are expressing it is of any type. Okay, so when you say any, it means any type can go here. It can be a boolean, it can be a what. Now you may think at first that this is good because if you write any, everything will go and you have peace. but actually this is now normal writing JavaScript. So if you are writing in any, basically there is no there was no need of you going TypeScript, because TypeScript is actually to force us to be disciplined and give the values, or give the types. Now in some scenarios, for sure, you cannot be sure of the variables. Now I have found myself in many scenarios, and in the future we might use any. Okay, so there is a reason why they put it there, and the reason being, in just in case you are not sure of what is this supposed to be temporarily, as you are looking for what it is, because it's not good to have any data in your application and you're not sure of its shape. Okay, but temporarily you can just say, I'm just going to put any for the app to work for now, but I'm just going to be researching to know what it is supposed to be. The problem with it is that if you say, for instance, here you want a name and you say hello name, you see you can say hi and you pass in a name, this will go. At the same time, you can say hi to 123 and you can see it also goes. And that's the reason, the problem of using the any, you are going to end up getting the bugs, the ones that we have been getting in normal JavaScript. So try to avoid the any type as much as you can until you actually fail and you cannot know what exactly to do or what to put. Temporarily you can just go ahead and define the any type. Okay, so this is in various places. I gave examples of them here. Now there's another one, any they called an unknown, and they brought an unknown type to simply the best way of avoiding using the any. Instead you can use an unknown. So instead here for instance, sorry, you can see here, instead of saying any, okay, instead of saying any, we have this name, and you can say an unknown. And then the good thing with an unknown, you can come and use type. You first check if it is a string and then you do this. Okay, that is the good thing with an unknown. And you see that now, like this one will not give any output because it is not going to be considered. Okay, so let's talk about another one, which is the union type. So the TypeScript union type, they are used when a value can be more than a single value. Now this is also a common thing. A value can have more than one types, and you're just going to see that one is going to be a common thing as we move on. Okay, so allow a variable to hold values of different types. For instance, you can have type 1 and type 2. So for instance, you can have a value which is a string, at the same time a number. Okay, and for instance, you can have this whereby the code, you can see here, I'm just going to copy this, and let me just go here down and I say union types. So we are now on the union types. So in union types, if you have something like this, you have a function and you're saying code, and you can see you can define and give options. You see code, and instead of saying on a string, you can see it is a string or a number, and this is acceptable. And this is what you call a union. Okay, so you can say console.log my status code, and you see you can pass in the number or you can pass in here. And even when you just do option chaining, this option types, if you just say function, okay, function, maybe let's give the function a name. Maybe this one is going to say what? Maybe it's a log number, whatever. So you can just come here and you say, for instance, this can be a number, maybe a, and let's go ahead and say console.log a. Now you can't just say give this one an option type. For instance, you could just come and say, when you just say this is optionally maybe a number, if you just give this something like this, if you hover on this, you can see that it is giving it a number or an undefined. So if I copy this, for instance, Ctrl C, I can remove this and then replace it with this, and this works. Okay, so you can just say A is going to be a number or an undefined. Just in case, if you do that and you just come here and you say log number, for instance, you will not be anyhow penalized, because as you can see now, the problem, if you do this, of course, this can be undefined. Let's say the problem, an argument for A was not provided. That's the difference, I guess. If you say it is a number or an undefined, you can just come here. Let's just say here string temporary, and we see. So if I pass in, for instance, 20, it goes. If I pass in 20, it also goes. But let me pass in a boolean. So you just say true, just like that. So you can see this is not going to go through. For instance, parameter type string or number, and assign you can't assign a boolean to string or number. So you can see you can use this. Okay, you can even say a color and you give it a different value. You give it something, as you can see here, value. You can initialize it to be 2, even more. They can even be 3 or 4. Okay, and this is what you call union types. We use these ones a lot. Okay, so now speaking of which, now we have what you call type aliases. Now to see what type aliases mean, so as you keep on doing, for instance, this, let's go back and look at an example whereby you have a function. Okay, so maybe you're having a function that maybe does what? Let's say maybe you have a function that calculates maybe simple interest. Okay, maybe simple calc, SI, calc, simple calc, simple interest. Okay, and let's say this one takes in a many things. For instance, it takes in principal, it takes in principal, it takes in rate, and maybe it takes in also time. Okay, just like that. It takes in principal, time, maybe also is a client, and then you can even take in more things. Okay, you just say take example of this, and you are saying, for instance, principal is going to be a number. Okay, and then you say rate is going to be also a number, and then time is also a number, and is a client is a boolean. Okay, just like this. And then inside here you can just say, of course, go ahead and say const, okay, si is equal to maybe principal. Okay, I just say maybe put a bracket. I'm not maybe here you can just say maybe this is going to be principal, and now times maybe rate times, is it like that? I think it's PRT, yeah. So it is principal times rate times time, and then maybe divided by 100 times 12. Okay, times 12, maybe something like this, and you can just go ahead, of course, and return. So you can just say return maybe the simple interest, just like this. Okay, and is client, we can just say maybe this one is not required. Let's just make it like that. Okay, so just come here and you can just say calc simple interest, and we can just go ahead and pass in things like 5,000, rate of 10, time of 5 months, and so on. And you see we have it clearly here. Now the problem with this function, as you can see, as time goes in, you have more and more parameters. Okay, you have more and more parameters. Now this can be really be stressing, because you are going to find here the code is unreadable because you have more parameters and each parameter need to have a value. So basically what you can do is also defining your own custom types. Okay, so this is why we look at type alias, what I just normally call just like custom data types. So here this is meaning like you are creating your custom data types. Okay, basically, so you are creating your own type, you define it, and then you can start using it. Okay, now when you are defining the custom type, you start with the word type. Okay, so for instance, you can say I'm defining a type, okay, of maybe, let's just say right now, interest. Okay, and then you can just go ahead and say this type is going to be of this nature. Okay, so you go ahead and define the type of this. Let's say is going to hold all these things here. Okay, so you're just going to copy this here. So you can just go ahead and say it's going to have interest, rate, time, and is client. So you can just go ahead and define them like this, and you notice you are differentiating them, you're not using commas but using these. This is even if you put commas, this code is going to help you to put back like this. So this is what we call a type alias, like a custom data type. You just go and define it, and then you can start using this in your code, okay, or in other places of your stuff. So a type alias is a name of any type. You can actually use a type alias to give a name to any type at all. So you can, for instance, have primitives. You can say I have type this, type email, I have type ID, type. So you can give any type, you can define it as your own custom type. You give it a name. That's the most important thing. For instance, type, then you give it a name, and then you define what is going to be stored in that type. For instance, in this case, a string. In this one is email, and in some cases going to have length of 10. So tuple, but the most type we're going to see that we normally use it for objects. Okay, because for this type like these small cases, we use the built-in types. But in the case you have like a bigger object for a complex scenarios, like you are fetching data or you are creating data in database, you have a huge object. Instead of relying on defining one by one, you go ahead and define your own type, give it a name, the way you can see here, user, and it has, for instance, ID, name, and so on and so forth. And then after defining it, you can now go ahead and use it in some scenario. Okay, maybe I can just go ahead and create another function here. Now that we have this, what did I do? Okay, so let me just go ahead and say here, for instance, function calculate interest. So you can say calc interest. Okay, and maybe it's supposed taking some values. Okay, so I'm just going to go here and say whatever, and I just put in some parameters. Okay, so it's just going to have principal. Okay, so it's going to have, for instance, some this, and you can see it is always in the object format. So you could just come here and also pass in, for instance, principal principal. Okay, principal. Let me just copy it here, guys. So you have principal, rate, time, and of course is client, just like this. So now you come and you say all these, they belong to interest. Look at this, guys. So you can define these outside and then come and assign it here. Okay, you can just come and assign it here just like this. Okay, so you can just go ahead and do the same thing we did here. Okay, you can just go ahead and do the same thing we did here, just like that. Okay, it has no problem. So but the good thing right now is that we have used this type, and if I just hover here, type interest, it has all this covered for you. Okay, it has all this covered for you, and there is no any complaints because we are using this. And this is how you create a type. So you create this type. Another advantage of using types is you can define them in different places and use them in other places. So they help us in code splitting. You can define all your types in one place, and then, and to give you an example, Control B, I'm just going to go in outside here. I'm just going to create a new folder called types. So I'm just going to say types, just like this, and then inside types I'm just going to create a new file, types.ts. So types.ts, just like this, and let's move this type I created here, this one. Okay, just cut it and bring in here. Now the only thing you can do, you can actually export this also. So you can just say export type interest. Okay, and you can either export it at default, but since we can put many things here, just simply export it as simple as this, export type interest, like that. Now if you come back here, they are not seeing this interest, cannot find name interest, they don't know where it is coming from. So we can come here and import it. So click here and click there, just like this, import, and we are good. It still has everything. Now you can use it in different values or in different places. You can go in page, you can create another page, still use this one. Okay, now one thing you can also do is you can also come here where we have imported it here. Now there is always a conflict when you look at this. It's just almost like an object, so sometimes they can always put this keyword type, okay, type, just to actually mean that this is a type. Okay, because you might be confused if, for instance, this is the data or it is a type. So sometimes we put this keyword type simply actually mean that this is a type, but even if you don't put it, it will still work. But it's good convention that you actually mention it as type, so that someone knows that this is actually a type, so that it's not like a data is confusing it with data. Okay, so you can see that now we have our type defined and it is coming from outside here. Okay, so eventually also we have another one which is just for instance which is similar to this, which is called interface. Okay, so interfaces are similar to types or type aliases, except they only apply to objects. Excuse me. So if you check on others like the type aliases, you see for them they can actually save any data type, the primitives, the strings, the tuples, everything can save, or you can define it in a type alias. Unlike the interfaces, they are specifically for objects. They only apply to objects, but they work in exactly the same way, the way we used the types. Okay, so for the type, you just simply define it using the keyword type. Okay, similarly the interfaces, so let me just put it down here, interfaces. Okay, so let me just say here I have here example, so function. Okay, so you can say function, and here I'm just going to pass in a user. Okay, or they just pass in here and we say name, email, and maybe password. So we can just come here and we could go and define a type. So I just show you, we could define here a type and we say export. Okay, export type user, just like that. Okay, type user, and then just come here. First of all, of course, give it equal like this, and then we can just say this is going to have name, which is going to be a string. It has email, which is also a string. Okay, and then it has also maybe password, which is also a string. Okay, and of course we can also have, like, for instance, verified, which is maybe a boolean. Okay, just like that. So I've created this and I've exported it, so you can just come here to this, and here you can just say the name, email, password is of type user. Okay, now I can just go ahead and import this from the user, and you can also see here, and you can also just put the keyword type. Okay, just like that. And if I just come down here, I have first of all a problem. So what problem do we have? Let me first create this. Okay, and if you hover first on it, you just give it a name, create user, for instance. Okay, so you can just have a function create user, which is taking in of this user type. Okay, so if we just try to create this function, just say create user, and let me pass in some names. So name, I'm just going to pass in John. Okay, email, it is john@gmail.com, and of course this is a string, just like that. And then for password is actually password, just like that. And this one is missing something like that. So you look at this, we still have this. You can see create user. Okay, they say that in the create user, they say function create user, we have this. Let's see, expected 1 argument but got 3. Okay, so you can see here it's supposed to be type user. So let me just come here and just simply put user, I guess, just like that. And then here, if you just come here and do this, so you see now they are saying argument of type string is not assignable to parameter of type user. And what is the user here? You can see user is an object, so you need to pass in something like this. Okay, they just pass in here like this, and this pass name here JB, email is going to be jb@gmail.com, password is password. Remove these ones are supposed to be now commas, just like this. Now, just in the case to show you that if I don't pass in, for instance, this verified, we are going to still have one problem. You can see here argument of type name string image string is not assigned with type this user. Property verified is missing in this type. So if, for instance, we are missing one key, they will not allow us to create anything. Okay, so now you just need to do this. Okay, so for instance, we can just go here in the types, we make this one optional, and I put just this question mark, and automatically, even after making it here, automatically it disappears here because now it is not required. Okay, so this is some of the tricks. Of course, we could just come here, create user, and we simply say console.log user. Okay, just like that. And of course, if you run this in the console, if you wanted, you see you are consoling the user. Okay, so this is some of the techniques of creating. Okay, we're talking about interfaces. Sorry, I've just created this as a type. So how do I create this to be an interface? So exactly the same way you use a type is the same way you use an interface. They only differ that types, they can work on all things, for instance booleans, typos, strings, numbers, while interfaces are only for objects, and they have extensively put it for objects. So the first thing to do is going this side and change this. So let me just duplicate this, simply copy and paste down here. So the first thing I'm just going to change this is changing it from a type to use the keyword interface. Okay, so that is the first thing. You must name your stuff as interface. You use the word interface. Okay, then you give your interface a name. They just say user. Okay, and then for it you don't actually put this equal sign. Okay, you don't have to put this equal sign. You simply create it as an object like this. I'm just going to go and also give it exactly the same things like that. Okay, now if you just look at the error we have, is that here is supposed to be small, by the way, sorry, this is supposed to be small interface, not capital. So you're supposed to have this, we have the same name here. Okay, duplicate identifier user. Now we normally prefix interfaces with I. It is not a must. Okay, it's not a must, but something which is recommended by developers. They use it most, that all interfaces begin with I to mean or to know that this is an interface, to differentiate them from types, because they can sometimes look exactly like types, but I can differentiate I normally differentiate them using here the I to mean the interface. So now I can export this now interface. Now if I come back this side, instead of using this user, I'm just going to use I user. Okay, so also import this. So you can see I've imported it the same way. On top here you're going to see it is having also a I user, and we're using it exactly in the similar way, no any change. So interfaces, they are used in the same way as types, but they have some key differences. Now we have already seen that these ones only work for objects, the interfaces. That's not the only difference. Another difference is that if you just go back here, for instance, we have this interface here. The difference comes if you want to extend. So what is extending? Interfaces have a nice thing called extending. Now to understand, extending is, for instance, if you had an interface called rectangle, which takes in height and width, and you want to create another one called colored rectangle, you can actually use everything that is in the rectangle, and then you extend it to the rectangle. So it will get all the properties in rectangle and it will bring them to this new one. Now to understand this, I'm going to go back here. So from this user, I'm just going to create an employee. So for instance, I can just say export. Okay, now I want to create a new interface. Okay, so I can just say interface. Okay, and I say, for instance, employee. So I can just say interface I employee. Okay, this, I'm just going to make it capital. I employee. Okay, employee, just like this, extends. Okay, I use the word extends to I user. Okay, I user. So if this was the structuring, to give you an example, if it's just like when you have two objects and you're trying to combine them. Okay, when you say interface I employee extends I user, meaning that you are getting all the keys inside the user, you are adding them inside the employee. So here we can add two things, for instance ID, which is going to be maybe a string, and then we can add another one, maybe the reg, maybe say the tax number, whatever, tax number, and you can say tax number. This is going to be a number. Okay, so now let's go and create any other person, any other thing based on this. Okay, based on this I employee. So if, for instance, you just go and create based on that, let's say const employee, okay, has I employee. We just import this from types, and let's go and give it some things. Okay, let's give it, for instance, only two things. Let's give it ID, which was, if you hover here, it was having a string. So I'm just going to say, for instance, one blah blah, and then I'm just also going to give it the second one. I just give it only these two, tax number. So if I give it only tax number here, tax number, like maybe 23. So if I just leave it at that, you can see they have this one, and they are telling you that scoped variable employee. Okay, let's just say maybe new employee. Okay, just like that, and it takes in this is redeclared. So you can see then you say ID type number is missing the following properties from type employee name, email, password. So all these ones are missing because they were extended. So when you extend everything that you have inside here, you have actually added it in here. Instead of duplicating all these ones, you simply extend. Okay, so you must just come and you also pass in name, email, and password. So you can just come here and say name, email, I can say here email at gmail.com. okay, and of course the last one is password, which is maybe password, just like this. So you can see we simply created a new employee using this I employee, and in this I employee, if you check it, we only have two things and others just came from the I user. So that is the extending, and it is a really nice thing, and I find it really more valuable. Okay, so you can also just go ahead and look at the comparisons between these two. Okay, you can read more. I wrote about so much documentation about it. So another one that is really common is TypeScript casting. So casting, if for instance you have something like this, let me just go here to page, and just going to put a concept here called casting. Okay, so casting, what they mean is, for instance, if you have x as an unknown, hello, but you are very sure this it had this unknown, but you want to treat this as a string, you can just say treat x as a string. This is acceptable. Okay, you can treat this, or you can just say I know very well this is going to be a string, and I'm just going to treat it as a string. And normally this is going to be things like environmental variables. If you're just like casting them in Next.js or something, you can always just like say I'm very sure it's going to be a string, so you can cast this as a string. Okay, you can also read more about casting. I gave more examples about it. Casting does not actually change the type of the data within the variable. For example, if you have x is equal 4 and you're trying to cast it as a string, and then you are asking for length, it will print undefined since numbers don't have length. So you only convert, it does not convert things, it only just treats it as a string, but doesn't mean it has converted this as into a string. That's why you see if you say dot length, it doesn't work. But if this was a string, it will work. Okay, because at first it had this an unknown type, and you're trying to cast it as a string, does not necessarily force this to convert. It does not necessarily convert, it simply treats as, and if it is not possible to find this as a string, it will not do it. As you can see, this will give you an undefined. Okay, so you can go ahead and read about it. The another one is TypeScript guards. Now TypeScript guards is really just like doing the let's just come here and give these examples. This example here, and I walk you through TypeScript guards. Okay, and then inside here I'm just going to have this, for instance, type. So you have type alphanumeric, and it is a string or number. We already have this add. I'm just going to name this one maybe to adding. Okay, so you have function adding, which takes in a, it is of this type here, and b is also of this type. And you can see in simple terms how you can use a type to define something very easy, like a union type, like here. And then inside here you can just check. So the type guard we are talking about is actually this one. Type of is a type guard. Like a type guard helps us check different data type scenarios. Okay, and type of is actually exists in JavaScript. Okay, but type guard is like a trick or technique of actually checking the data types, and then you do different things if there is a different data type. For instance, you can see here, if type of A is number and type of B is number, then do the summing or return sum. If type of A is string and type B is string, they are doing now concatenation. Okay, they are concatenating the words, and this is can be so much helpful, like trying to do that. And you can see if it doesn't match any of this one, throw new error, invalid arguments. Okay, yeah, so this is how we use what we call type guard. Okay, or TypeScript guard. You can use them to do different check different types, and then you do handle different scenarios. Okay, so the last concept I think we're going to look at is TypeScript generics. Okay, now most people don't actually understand. This is like a most complicated concept in TypeScript. I find most people googling it, and even me, I was googling it over and over. I try to make more notes on it so that you actually understand it really well. Okay, so just like zoom in really much so that actually we look at what is going on. So TypeScript generics. use case and examples to understand what TypeScript generics are. Let's look at the use cases. Okay, let's start with a simple example why you want to print the value of an argument passed. So let's say you have a function called function print data. Okay, so clearly we take in data and is of type number, and we have console.log data, just as simple as this. If we print 2, it will go ahead and console on the console.log the data. Okay, just understand this function. We have print data. Okay, we pass in the data. In this case, we are passing data as a number, and it consoles it down. Now suppose that you want to make the print data a more generic function where you can pass in any type of argument to it, like a number, string, or boolean. So you might think to take the approach like this. You may just say, if I want to pass in data type, I can just come and say data, and I say the data is either a number or a string or a boolean. Of course, this is smart thinking. At least if you think of doing like this is smartly and is good, because now if you pass in a number, it will be a number. If you pass in a string, will be a string. If you pass in a boolean, will also be a boolean. Okay, so for instance, you can pass in 2, you can pass in a hello world, and you can pass in true, and all these ones are valid according to this function. Okay, so but in the future you might want to print an array of numbers using the same function. In that case the types will increase and it will become cumbersome to maintain all those different types. So as you keep on adding different types here with this union operator, so you keep on with union, you put like string, then arrays, then what, for instance, it can even be array of numbers, array of strings. So you cannot really manage how this one goes, and this is where generics come into play. Okay, so generics, they help us to generalize, okay, the types. For instance, generics are like variables. To be precise, type variables. They are type variables or type arguments that store the type, okay, for example, number, string, or boolean as a value. So you can solve the problem above using generics as this. So just relax, function print data, and we pass in angle bracket outside. We pass in the angle bracket outside with a T, then inside we have data, it takes in type T. So this T you're seeing here is actually a type. And in this case, we are trying to mean a general type. It can be a boolean, it can be a string, it can be an array, it can be an object. So basically, the type you pass in is going to be given to the data as the type. And JavaScript types is going to using type inference to know what to return. Okay? So in this case, if you pass in a string here, it's going to be data as a string. If you pass in an array here, it is going to be data as an array. If you pass in boolean here, it's going to be data as boolean. And that's just simply what generics are. They simply generalize and give us ability to pass in the data type we want, and simply returns that data type at the end of the day. So in the above example, print data generics, there is a slight difference in the syntax. Okay, you use a type variable inside angle brackets after the function name. In this case, it was this T. You then assign the type variable to a parameter data, for instance, this data T. And let's just see more of the differences. So to use generics, you need to use angle brackets. That's one thing you have seen. And then specify a type variable inside them. Developers normally use T, X, and Y, but it's not a must. Okay? You can use any variable you want, but we normally use T just to mean type. Okay? But you can put X, you can put Y, and even in the case when you have more variables like T, Y, you can use more than that. Okay? So now, whatever argument you pass in to the function, it gets inferred and there is no need to hard code the type anywhere. Okay, so for instance, if you just do like this and you pass in 2 here, this 2 will be passed in here and is going to be inferred as a number. If you pass in hello, it's going to be passed in here and passed in here, and to just going to notice a string. And you can go ahead now, you pass in an array. Okay, you can pass in an array and to still see that this is array of numbers. If you pass in this or this, it will still all work. Okay, so you can also look at another example whereby you have data still, but you are passing in this time x and y, and you can have data 1 as x and data 2 y, and this still works the same way. So what I can just tell you about generics is that you are trying to generalize a data type called t. That's why you just use t, and then when you pass it, it is going to be passed down the road. Okay, so you're just going to be seeing it when we come to things like use state and others. We are going to be looking at more details. So this marks the end of the first episode or the first part of TypeScript basics. If you just scroll down, there are some more other things we can just use, more especially TypeScript in Next.js, which was our second part, as I told you in this here. Let me show you. TypeScript for beginners, then TypeScript in Next, and TypeScript in production. So we have those 3 parts, and we have managed to complete the first part, which is actually TypeScript basics. We have looked at all the basics in TypeScript, and the next thing you're going to look at when we come back in another episode, we're just going to be looking at TypeScript in Next.js, where we look at things like how do we use it in use state, hooks, creating buttons, creating the nice things we have been doing, and using it at a more robust way. Okay, so this is going to be coming up next, and yeah, that's what is going to come up next in this the next episode. So thank you so much for watching this episode, and thank you for subscribing. If you haven't subscribed, please subscribe and check the link for the full course in the description, and you can sign up for the waiting list, or if the course by the time you have it has already started, simply sign up for the course.